Yeah, good evening everyone. Good evening. Let me know audio video okay or not. Check everyone, audio video okay or not. Screen is okay or not. Check one time. Yeah, let me go to today's class starting. I'm going. Yeah, I'm starting now. So in yesterday's class, we started from here. So yesterday's date also I written. So first I will go to roughly whatever happened in the yesterday's class. I will go roughly for that, right? Afterwards, we'll move to the today's class. Okay. Think if it is okay, so let's start now. Just give me a minute. Right. Right. I think I'm going ahead. Yeah. So yesterday 16 12 25. So I started the graph theory. Right. So graph definition I said, right? Graph is the combination of vertices and edges. I give an example one. I took one graph G1 which contain 4 vertices and 5 edges. Okay. And one more thing I said to all the people, degree of any vertex is nothing but number of edges associated with the vertex A. Degree of A means how many edges are associated with the vertex A. Right? Circles are known as vertices. Right? So between two circles, one line is there, that is called edge. So this graph contain 4 vertices and 5 edges. Right? Degree of any vertex is nothing but how many edges are associated with that. Right? I give an example, one more example, example 2. Right? In this graph, if you observe, 5 vertices are there, A to E. Edges are, I think, 8 edges are there, E1 to E8. Degree of A is 3. Degree of B is 3. Degree of C is also 3. Degree of D is, I think, 3. Degree of, degree of D is 3. Degree of E is 4. Right? And one more thing is, if you add all the degrees, sum of degrees is equal to sum of degrees is equal to, right? So 2 into number of edges. If you want, you can check. Sum of degrees, it became 16, can be written as 2 into 8, where 8 is the number of edges. Why, you may say that, sir, why number of edges? Why sum of degrees became double, sir? You may ask that. Right? The reason is very simple. Sum of degrees became 2 into E. Why double came? Double edges came means if you take any edge, every edge will count to degree as 2. Because left side person also counted this particular edge. Right also counted. That is the reason double came. That is the reason double came. Edge, right? And one more thing I am writing here. I'm writing here one more thing. Please careful. Everyone observe here. If you observe clearly here, so note I am writing. Note. Understand here? Every edge will count. Every edge will count degree by 2. Degree by 2. Every edge will count to degree by 2. Right? If anyone having any objection, let me know. Every edge will count degree by 2. Right? That is, I think, most probably everyone is comfortable with that. So that is the example 2. Let's go to example 3. In the example 3, if you observe, there are, I think, 6 vertices, A to F. There are 11 edges, E1 to E11. Check if you want. Right? Degree of A is 3. Degree of B is, I think, 4. Degree of C is 4. Degree of D is 4. Degree of E also 4. Degree of F is 3. Sum of degrees you count. It became 22. Can be written as 2 into 11, where 11 is the number of edges. So sum of degrees is equal to 2 into E. Everyone know this. Right? Example 4 also I taken. If you want, you can check. But in the example 4, I want to verify. I want to inform you what is self loop, what is parallel edges. With one edge only, if you can make cycle, With one edge only, if you can make cycle, that is called self loop. With more than one edge, if you make cycle, that is called loop. With one edge, if you make cycle, na self loop. With more than one edge, if you make cycle, na that is called cycle, or you can say loop also. So degree of every person. Remember everyone, right? Self loop will add degree by 2. Self loop. Let me write. Self loop. Self loop will count degree as 2. Every edge will contribute 2 degree. Self loop also will count to 2 degree, right? So some people are asking, self loop will count to 2 degree, okay, but what about one edge, right? When you take one edge, na, left person also counting, right person also counting. That is the reason sum of degrees is 2 into e, right? Every edge will count to, right, degree by 2, because left person also count, right also count. Self loop will count to, right, degree as 2, because see, this also counting, this also counting. Please careful, don't misunderstood, right? The purpose of this one is right, I want to confirm to you parallel edges and self loop. Let me check. A degree, if you observe, 2 plus 3 5. B degree, if you observe, 3 plus 2 5. C degree, if you observe, C degree. Just wait, someone is calling. Hope it's customer care, maybe. Let me check one time. Yeah, perfect. Yeah, it's normal only. So if you go to the D, if you go to the C, na, C degree, self loop is there 2, 2 plus 4, 6. If you go to the D degree, if you go to the D degree, go to the D degree also. If you go to the D degree, na, so I think 3. Just wait. Just I think 1 minute you have to give. Let me try once. Sorry for inconvenience. Just 1 minute. 1 minute. Just I'm coming. I'm just coming back. Just 1 minute. Yeah, so sorry for inconvenience. I hope audio video will be okay. So let's check one time. Let's check one time. Yeah, let me try one time. So if you go to the degree of C, which is 6. Degree of C is I think 4 plus 2 6. Degree of D, so 3. Degree of E, I think 3 plus 2 5. Right, so graph 4 sum of degrees, if you count, which became 24, which becomes 2 into 12, right, which will become 2 into 12. I think 12 is the number of edges. So remember, self loop will count degree by 2. Self loop will count degree by 2. Let me know any objection from anyone having any small doubt also, you can ask me. So can we move to next? I think until now we done it. Until now we done it. So let's go to next one. Let's go to next one. So I want to suggest to everyone, I want to suggest to every person I want to suggest one thing. Right, I want to suggest to every person one thing. So if you are preparing seriously for 2027, 27 people, right, regular batch is better. EPT providing variety of courses, right? Many courses are there. Whichever course you want, you can select. If you are preparing for 2027, this is better. 2028, this is better. Right? So if you are looking for crash course for 2026 people, so this is rank improvement course is a practice course. 2026 people, 27 people, 28 people, anyone can buy that. So mentorship, if you have small doubt also, at anywhere, any small doubt also, you can clarify with the help of mentorship. 26 people, 27 people, 28 people, placement people, everyone can take it. So test series, right, 2026 people can take the test series, right, 100 tests are there, you can take. Now come here now. So as I mentioned to you, self loop will count degree by 2. Sum of degrees is equal to 2 into E, right? So that is a formula I written. Sigma E is equal to 1 to N. Degree of Vi is equal to 2 into E, where 2 into E is an even number. E is not even. 2 into E is even because of 2 into anything, right, is going to be even number. So it is a number, right? Sum of degrees are even. Sum of degrees are even. I am writing that also 3. Sum of degrees is always even. Is always even. Sum of degrees is always even. Right, please take care this also. Sum of degrees is always even. Okay, I think you are absolutely fine now. You are absolutely fine now. Let's go to one more important point. Can you see this one? Let's go to one more point. First, I will go back and I will show to you, right? Then we can talk about, right? Can you see here? I'm using some other color. Let me use maybe green color. I'm using green color. Everyone see, if you observe clearly, degrees all we calculated. See correctly, everyone. So degree of A, so I think it is a odd degree. It is also odd degree. It is odd degree. It is also odd degree, right? I think 2 odd degree people only raise. Remember number of vortices with odd degree. Odd degree vortices. Number of vortices with odd degree is always even. Odd degree vortices are always even. For more clarity, you can go to this example also. How many vortices with odd degree? Check. 4. Number of vortices. Number of vortices with odd degree. With odd degree. 4, which is even. Number of vortices with odd degree, which is 4, which is even. So that is also okay. Can you come here and check? Right, degree of this person 3, degree of this person 2, degree of this person 3, degree of this person 2. I think number of vortices with odd degree 2, which is even. Right, so remember number of vortices with odd degree is always even. I am writing that also. Fourth point, number of vortices with odd degree is always even. Number of vertices with odd degree is always even, right? So if you want, I see this one. See everyone, A here, B here. When you add first time, when you add first time, right? So one came. So right, I think two people at a time one came. Now suppose if you add one more, right? See, right? So one more came, because of it is already odd. You added one more also, it became even. So previous odd and this odd, right? Number of vertices with odd degree always even. Can you remember this? Until now everyone is comfortable. Now concentrate one important topic. Now concentrate. Now graphs are two types. Now everyone try to understand. Graphs are two types. One is simple graph. Graphs are two types. One is simple graph. So another one is multi-graph. Graphs are two types: simple graph, multi-graph, right? So remember in the simple graph, some people are asking, sir, what is the difference? Name itself saying multi-graph, name itself saying simple graph, multi-graph. What is the meaning of multi-graph is, in the case of the multi-graph, see this one, self loop is allowed, or parallel edges also allowed, right? In the case of simple graph, self loop not allowed, parallel edges not allowed. This is the major difference. Both are not allowed. In the case of simple graph, self loop and parallel edges both are not allowed. Anyone also not allowed, both also not allowed. In the multi graph, both allowed, anyone also okay. This is the difference. So if you take A, if you take B, right, like this, self loop is not allowed. It is not allowed, but here allowed. Right? Next one. So if I take C, if I take D, right? So one edge there, one more edge. So like this, not allowed. Parallel edges are not allowed. But here if you observe, parallel edges also allowed. So careful. This is the difference. Right? Graphs are two types: simple graph, multi-graph. In the case of simple graph, name itself saying simple. Self loop is not allowed. Parallel edges also not allowed. In the case of multi-graph, self loop also allowed, parallel edges also allowed. I think everyone is absolutely fine. Let me know. Small doubt also there. In the comment section, you can comment. Little doubt also there. In the comment section, you can comment. Right? Fine. Perfect. Now observe. Very important one. Please observe here. See this. See correctly this. A, B, C, D, E. Understand this. This is also very important point. A, B, C, D. A, B, C, D. So if you observe clearly, this is the 4 vertex graph. It is a 4 vertex graph. Sorry, 5 vertex graph. Assume that this graph contains 5 vertices. Observe clearly. We are talking about right, simple graph only. In n vertex simple graph, understand everyone, in n vertex simple graph, first point, minimum degree of any vertex, minimum degree of any vertex is equal to, if you want you can check, in the simple graph, in n vertex simple graph, minimum degree of any vertex, I think 0. See, it is not necessary every person is connected. It is not necessary. So in the n vertex simple graph, minimum degree of any vertex is 0. Now next question is maximum degree of any vertex, how much? Let's check. Maximum degree of any vertex is equal to maximum degree of any vertex is equal to, let's see, 5, I think 5 people, maximum degree is adjacent to all other people, is adjacent to all other people. So I think for 5 vertices 4, for n vertices n minus 1. Understand this. In n vertex simple graph, minimum degree of any vertex is 0, maximum degree of any vertex is n minus 1. This is for simple graph, right? I think some people are asking, sir, why not? Sir, ready, sir, why not n, sir? If at all n there means, I think he is adjacent to himself also, not possible. He is adjacent to himself means self loop. Sir, why not n plus 1, sir? Right? I think that means parallel edges. Why not n plus 2, sir? That means parallel edges. That means self loop. So please careful. These are not possible. These are not possible. In n vertex simple graph, minimum degree of any vertex is 0. Minimum, because it is not necessary every 2 people are connected. It is not necessary. Some people may not connect to anyone. So minimum degree 0, maximum degree is n minus 1. So some people are asking, sir, simple graph, okay, but what about parallel edges, sir? Sir, what about parallel edges, sir? Right? We'll see this. What about parallel edges? Understand this also? Understand everyone this? Right? See this one. In n vertex, remember, multi-graph. In n vertex multi-graph, right? One, see this one. One. Minimum degree of any vertex is minimum degree of any vertex is equal to 0. Minimum 0, okay. But what about maximum? See the answer. What about maximum? Maximum degree of any vertex is equal to maximum, infinite, no boundary. You can keep self loop, you can keep parallel edges, many parallel edges you can keep, right? In n vertex multi-graph, careful, understand here everyone, understand. In n vertex simple graph means no self loop, no parallel edges. Minimum degree 0, maximum degree n minus 1. Next one, multi-graph, minimum degree 0, maximum degree infinite. In my opinion, everyone got it. In my opinion, everyone got. Do you have any doubt till now? Do you have any doubt till now? Let me check. Anyone having small doubt also? Let me know. Small doubt also. So, ready, sir? I have this doubt. You say to me, I will help you. Minimum degree fine, maximum degree fine. So if you okay, we can move to the next one. Can we move next one? Minimum degree we written, maximum degree also we written. Can we move to next? Check one time. Minimum degree, maximum degree. So remember simple graph, no self loop, no parallel edges. Right? No parallel edges, no self loop. So maximum degree n minus 1 only. Why not n? If I keep n, maybe parallel edge there. If I keep n plus 1, maybe self loop is there. If I keep n plus 2, maybe parallel edges, maybe self loop. N plus 3, maybe parallel edges, maybe self loop. But in the case of the multi-graph, they are allowed so infinite. I think everyone almost got it. Yeah, someone is saying some doubt. Let's check once. Why not n plus 1? If you keep n, right? Because so many parallel edges are possible, so let me check this. Someone asking why not n plus 1, right? When you say n plus 1, see this one. When you say n plus 1, I think 5 vertices, 4 already there, right? So careful everyone. So I am not saying the sum of degrees. I am saying the maximum degree. I am saying minimum degree. I'm not saying sum of degrees. I'm saying maximum degree, minimum degree. Can you see this one? I think to this person, if I keep the maximum degree, he is adjacent, right? He is connected with other people. He cannot connect himself. He will be connected with other people. I think total 5, other means 4. Suppose if anyone say 5, he may be connected himself, then it is a self loop. Self loop means it is not a simple graph. Next one, I think he will be connected to other person one more time. It is called parallel edge. It is called parallel edge. So that is the reason. You may say that, sir, how infinite, sir? How infinite? See this one? This may be parallel edge. This may be parallel edge. This may be parallel edge. Many times you can write. Many times you can write. So when you keep many times, automatically it will become infinite. That is the reason. Automatically it will become infinite. That is the reason. I think we covered what is the simple graph. We covered what is the simple graph, what is the multi-graph. We are already covered. And one more, remember, sum of degrees is equal to 2 into E. Now understand everyone. Everyone see this. Everyone see this. A. This is also very interesting. Can you see this one? B, C, D, E. Understand this. This also very interesting. This problem also interesting. Can you see this? A, B, C, D. A, B, C, D. Yeah. Now see this one. I am keeping directions. I am keeping directions. I am keeping directions. If in a graph, if you keep directions, it is going to be directed graph. No directions are there, undirected graph. Directions are there, directed graph. Try to understand. This is a directed graph. Let me give the number, whatever name you want, you can keep. Assume that it is a graph G6. Graph may be directed, graph may be undirected. If no direction, undirected. Directions are there, so directed graph. This is a directed graph. I am writing now. Directed graph. G6 is directed graph. G6 is directed graph. Which is a short name. People used to say digraph. G6 is digraph. Otherwise, I think it is really not required. Unnecessary confusion. So simply write down G6 is a directed graph. Directions are there, so directed graph. Directions are there, so directed. Now let's find out. Interesting thing. Right? Interesting thing. Everyone observe degree. Degree. What is the degree of A? G6 is a directed graph. It's okay. I understand. Degree of A. Remember everyone, because of here directions are there, no degree. This is called in degree, out degree. In degree, how much? In degree, how much? Out degree, how much? Because of it is a directed graph, people are coming or going. Going is called out degree. Coming is called as in degree. So can you help? Inside A, how many people are coming? Inside A, how many people are coming? Only one. Outside A, how many going? Outside A, how many going? Two. Similar way. I think A over. Let's go to B also. B in degree, how much? In degree. In degree of B. In degree of B, how many people are coming inside B? 2. Out degree of B. Out degree of B. From B, how many people are going outside? I think 1. Let's go to C. C, right? So in degree of C, how much? Check once. How many people are coming inside C? 2. Right? How many people are going outside C? Outside C, no one. Right? I think C also completed. Let's go to D. So in degree of D, verify how many people are coming inside D. Inside 2. How many people are going out of D? I think no one. I think D also completed. Let's go to E. Everyone observe E also. Let's check. So what is the in degree of? E? In degree of E is how many people are coming inside? I think no one. Next one. What is the out degree of E? How many people are going out of E? I think 4 people. 4. So the people who are coming inside is the in degree. The people who are going outside, that is called out degree. Suppose directions are not there, no in degree, no out degree. Simply degree. For directed graph, in degree, out degree. For the simply undirected graph, simply degree. Now, if you observe clearly, observe everyone, very, very important one. Sum of in degrees count. Sum of in degrees count. If you want, you can count sum of in degrees, count 1 here, 2 here, 2 here, 2 here, 0 here in degree. I think 1 plus 2 plus 2 plus 2 plus 0. I think if you observe only 3 times 2, 6, 6 plus 1, 7. Sum of, right, sum of in degree is 7. Right, next one, sum of out degree also find out. Sum of out degree also find out. Sum of in degree 7, I understood. Sum of out degree how much? Sum of out degree check. 2 here, 1 here, 0 here, 0 here. Out degree check. 2 plus 1 is 3. 3 plus 4 is 7. So I think it is 7. Next one, if you want, you can verify number of edges, how many count. In the given graph, number of edges, how many count. Number of edges, if you count, if you count number of edges, 1, 2, 3, 4, 5, 6, 7. Number of edges are 7. So what I mean to say is sum of in degrees is equal to sum of out degrees is equal to number of edges. Sum of in degrees is equal to sum of out degrees is equal to number of edges. So what I mean to say is from this I want to say one thing. If at all directions are not there, if directions are not there, no in degree, no out degree, then what you do is in degrees, out degrees, combine it. Directions are not there, right? No in degree, no out degree, just combine. 7 plus 7 is 14, which is equal to 2 into 7, nothing there. So this is normal story. If I don't say, you may feel that it is a complex statement and all. Or you may ask me, right, some point of time, sir, you covered only for a, right, undirected graph. Sir, what about directed graph? Yeah, sum of in degrees is equal to sum of out degrees is equal to number of edges. I'm feeling that everyone is comfortable. Do you have any doubt? Let me check. Any doubts are there? Right, check anyone having any issue? In degree, out degree, sum of degrees, sum of in degrees is equal to sum of out degrees is equal to number of edges, right? So next one is simple graph, next one is multi graph. You have to verify. Everyone try. Any doubt is there? Sir, I have this doubt, I have that doubt. You ask me, I will help. Yeah, can we move next then? Yeah, I think if you are comfortable, we can move next. Now go to the next one. Now it's a very important topic. Write down types of simple graph. We will discuss only simple graph. Multi graph, nothing to discuss, because multi graph, you take any example, it will goes to almost like infinite. Any question if I ask on multi graph, you may say answer as infinite. Right, I'm repeating once again. If I ask any question on multi graph, most of the answers are infinite. So we don't discuss multi graph, we will discuss the simple graph. Right, let's discuss simple graph. Let's discuss simple graph. Careful everyone. Simple graph. Everyone observe. So our discussion is about simple graphs only. In the simple graph, first model, let me talk about first model. Simple graph, first model, right? So let's write the few example. Example 1. In the simple graph, first model I am writing. First model. See the first model. A, B, C, D. So many simple graphs are possible. I am writing first model. This is one simple graph. Assume G1. So many simple graphs possible. First simple graph model I am taking. So this is the one type of simple graph, where in the simple graph, every person degree is 0. Right? There is a simple graph where in the simple graph every person degree 0. This simple graph normally name called as 4 vertex null graph. This is called null graph. 4 vertex null graph. 4 vertices are there null. Why it is called null graph? Number of edges are 0. Null graph means number of edges 0. It is a 4 vertex null graph. 4 vertex null graph. Why it is null graph is number of edges are 0, right? Next one more null graph I am giving. Can you see this one? It is also null graph. It is a G2, right? It is going to be 3 vertex null graph. 3 vertex null graph. Null graph means 0 edges. This is also okay. First of all, what is the meaning of null graph? In the given graph, number of edges 0 means every person degree 0. Every person degree 0 in the given, right? Remember, there is no self loop. They remember, because it is a simple graph. We are discussing about simple graphs only. In the given simple graph, every person degree 0 or number of edges 0. That is called null graph. Right? So if at all graph contain 3 vertices, 3 vertex null graph, because number of edges are 0 and vertices are 3. 4 vertex null graph, number of edges 0, 4 vertices are there. Right? Like that. That is this is going to be, I think, example 2. It's going to be example 2. Let's go to example 3. Example 3. A, B, C, D, E. A, B, C, D. A, B, C, D. Right? So now observe here. A, B, C, D. Now observe. This may be example 3. That is okay. But if you observe clearly, some people are asking, sir, edges cannot be there. Na? Yeah, exactly. My concentration is here, only null graph. My concentration here is only null graph, right? I think it is a 5 vertex null graph. It is a 5 vertex null graph. Null graph means 0 edges, but vertices we don't know. You have to say vertices. Right? Now I am writing the note. See this one? Note. Note everyone. Everyone observe. In n vertex null graph, note. In n vertex null graph, total edges is equal to 0. Okay? Total vertices he already mentioned, right? N vertex, na? N vertices. Total vertices N. That is on everyone. So in all the simple graphs, right, smallest simple graph is null graph. In all simple graphs, smallest simple graph is null graph. Try to understand. Right? Try to understand. So, and one more thing is, if you are preparing for the advantage, if you prepare for gate is, if you prepare to gate examination, advantage is you can get the gate, no objection, right? You can get the PSUs also. Many of my students are there. They tried the gate. Sometimes gate may not come, but gate syllabus and right, all the PSU syllabus almost similar. Right? One time gate preparation is equal to, right, gate also, ISRO also, DRDO also, NIC also, NILET also, BARC also, same thing. Same, and 1 or 2 subjects are different. So this course, if you take, those also will be covered. Gate CSC plus top PSU course. It is a full course, right? It is a full course. So what I mean to say is, whatever gate is there, these particular exams also contain same. 1 or 2 subjects are different. Those also will be included in the top PSU course. And interesting thing is, 80% discount is going on. Tomorrow is the last date. 80% discount going on. Tomorrow is the last date. 80% discount going on. Some people are asking, sir, Reddy sir, while preparing to gate examination, can I crack up, right, placements also? Of course, this course, right, gate CSE plus so DA plus. Some people are asking, sir, can I write the DA and the CSE and placement? All combinedly will be covered in this course. It is also right. So tomorrow only last date, 80% discount going on. You can utilize. So using this course, gate CSE, gate DA, and placements, right? All 3 can be covered. Right? So I want to cover. Yeah, if you think that you want to cover only placement course, you can go for this. This is also right. 80% discount going on. You can utilize. Right? Fine. So programming courses also there. Full stack web development is there. Full stack app development also there. Right? 100% job guarantee course also there, so you can utilize. Now come here, now come here. I'm thinking that everyone is okay. Now come here, see this one more model. Everyone observe, everyone observe. Null, right? Simple graph, one more model. Simple graph, one more model. See this one, A, B, C, D. Simple graph, one more model. Understand everyone. Assume that it's a one graph. Let us assume that graph is G1. Okay. So 4 vertex simple graph, maximum degree 3 na. 4 vertex simple graph, maximum degree of any vertex is 3. So I kept 3 here. Let me keep here also 3. Let me keep here also 3. What I want to say is, in the given simple graph, every person you kept a maximum degree, right? Every person you kept the maximum degree. That is called complete graph. That is called complete graph. So complete graph with 4 vertices. People used to represent K4. K4 means complete graph with 4 vertices. K means complete. Actually, K means, right? Yeah, complete means starting with C, na? But why they written K, right? I think C will be given to some other graph. That is the reason. So C4 means cycle graph, but here it's a complete graph. It's a 4 vertex complete graph. Try to understand. Let me draw one more graph. One more simple graph. Let's say this: A, B, and C. A, B, C. So I think 3 vertices. Let us that this graph name is G2. Assume. So 3 vertices. Every vertex contain maximum degree 2. This is called 3 vertex complete graph, K3. So let me write one more thing: A, B, C, D, E. A, B, C, D. A, B, C, D. So if you observe clearly, it's a 5 vertices where everywhere 4 degree check. 5 vertices everywhere maximum degree. Everywhere maximum degree. So 5 vertices where everywhere completely fully there. So it's a complete graph with 5 vertices, K5. This may be graph 3. This may be graph 3. So remember, in the similar way, because of you are absolutely fine. So listen, note, it is a very, very important one. Note, in n vertex simple graph, in n vertex complete graph, in n vertex complete graph, which is also called as Kn, total number of vertices are n. In n vertex complete graph Kn, total vertices are n, right? That is okay. Total edges, if you observe, right? Total edges, if you want, you can check. See this one. I think in the K4, every 1 degree 3. In the K3, every 1 degree 2. In the K5, every 1 degree 4. So in the Kn, right? Every 1 degree n minus 1. See this one. N minus 1, 1 person. Total, right? Total edges he is talking. Total edges. So n minus 1, 1% degree. One more person, n minus 1. One more person, n minus 1. It will continue. How many time? N time. It will continue n time. So if you count total, I think it is the sum of degrees. This is almost like n time. So it is n into n minus 1. So it is the sum of degrees. If you want total number of edges, do by 2. Sum of degrees, which is going to be 2e. If you want only e, by 2 you do. So the total number of edges are n into n minus 1 by 2. Right? N vertex complete graph, total number of edges are n into n minus 1 by 2. Y by 2, n into n minus 1, right, will give sum of degrees. Sum of degrees is 2e, but you want e. Total edges means you want e, right? E is equal to sum of degrees by 2, n into n minus 1 by 2. So this is for complete graph. Remember everyone, in all simple graph, biggest graph is complete graph. In all simple graphs, smallest graph is null graph. In n vertex null graph, right, total number of edges are 0. In n vertex, right, in n vertex, so right, complete graph, total number of edges are n into n minus 1 by 2. Let me know any objection. Let me know if you have any objection. Sir, I have this doubt, sir. You ask me, I will help you. You just ask me, I will help you. Fine, can we move next? So we done the, in the simple graph, null graph we done. In the simple graph, we done the complete graph. Let me know if any objection. Small doubt also there, we can move to the next one. Small doubt also there, please let me know. We can move to the next one. I done the null graph, I done the complete graph. Two graphs I covered. In simple graphs, these are the two smallest graphs and biggest graph. Simple graph, smallest graph is a null graph. Biggest graph is, right, complete graph. Let me know if you have any objection. Sir, ready, sir, I have this doubt. You ask me, I will help. Check one time. Can we move next? Can we move next? Check one time. Can we move next? Null graph over, right? Complete graph is over, right? Some people are asking, sir, can we go to further graph? Let me check that also. Let me check that also. Let me check that also. One more model is coming. Understand this. Understand this also. A, B, C, D. A, B, C, D. Right? Understand this. Understand everyone? If you observe clearly this graph, if you observe clearly this graph, in this graph, every person degree is 3. Check. In this graph, assume that graph name is G1. In this graph, every person degree is 3. Every vertex degree same. Every vertex degree same. And one more thing I am writing. Every vertex degree is 3. Right? This is also called as, right, in the given graph, every vertex degree same. Every vertex degree is 3. Then it is called as 3 regular graph. This is called 3 regular graph. In the given simple graph, every vertex degree is 3. That is called 3 regular graph. So let me write one more. Let me write one more thing. A, B, C, D, E, F, G. Some vertices. Assume it is another graph. This is G1 graph. It may be G2 graph. Now understand. Understand in the G2. Yeah. So if you see the second graph, every person degree 1. Every person degree 1. So every person degree same. So let me write now. Every vertex degree same. Not only that, every vertex degree. Every vertex degree 1. So which is also called as one regular graph. One regular graph, which is also called as one regular graph. Try to remember, in the given simple graph, every person degree same. In the given, I'm repeating once again, in the given simple graph, every person degree same. That is called regular graph. Suppose every person degree 2 regular graph. See, every person degree is 3, so 3 regular graph. Every person degree is 1, same, that is okay. Every person degree 1, so 1 regular graph. So that is called regular graph. Now let me write. Now let me write. This is a very, very important one. See the note. See the note. In the given simple graph, in the given simple graph, every vertex, in the given simple graph, every vertex contain degree k. In the given simple graph, every vertex contain degree k, then it is called as k regular graph. In the given simple graph, every vertex contain degree k, then it is called as k regular graph. K regular. Now some people are asking, right? So let's see this one. First point. K regular graph contain. K regular graph contain. Right? So let me write. In the given simple graph, every vertex contain degree k, then it is called as k regular graph. Okay, that's okay. So see this point, very, very important point. See this one. In two, in n vertex, k regular graph, in n vertex k regular graph, total number of edges is equal to, remember every vertex degree k, like that n people, n into k, it's called sum of degrees, do by 2. This is the number of edges. Every person degree k n times, so nk, which is going to be sum of degrees, is 2e, do by 2, so total number of edges will come. So this is going to be very, very important statement. This statement is very, very important. In n vertex k regular graph, in n vertex k regular graph, total edges is equal to nk by 2. nk by 2. In n vertex k regular graph, total edges is equal to nk by 2. Right? This also I think you are comfortable. This also you are comfortable. Right? In tomorrow's class, we will discuss the remaining things. Let me know if anyone having any doubt. Till now, do you have any doubt? I'm going slowly now, so because right, many people have to join, some people not able to come because of their exams are going on, right? So that is the reason I'm going slowly. Once classes are, everything is perfect, right, we are going to cover, right, more faster. So it is our promise, right, within 15 days, 15 to 20 days, this subject will be over. 15 to 20 days, discrete mathematics will be over. Every subject don't take more than 20 days. 15 to 20 days, it will be over. Right? So as I mentioned to you, 80% is offer going on, please utilize. 80% is offer going on, please utilize. Right? 2026 people can go for crash course. They can go to crash course. Right? They can go to RIC course. They can go to test series. Right? Next one, 2027 people. 2027 people can go to, right, regular course, RIC course, because it is a practice course, test series also. 2028 people can go to foundation course, RIC course, and test series. Okay, fine, perfect. So see you in the next class. Right? So small doubts also there. It is our WhatsApp number. Please ping us. We are going to help you. Thank you. Thanks everyone. Good night. Good night, everyone.